Hi there, I'm Mr. Orr. Today we are going to start looking at section 7.5, glide reflections and compositions. And as I said at the end of the last section, what this one does is to take a figure like a triangle, and we're going to do several things to it. Let's say we're going to rotate it, and then we're going to flip it, and then we're going to slide it. So we're going to do all three things to this triangle and see where it ends up after we do those things to it. Now, to do that, we first have to start talking about certain kinds of rotations. I don't know how well you can see this, and I might just, I don't know if it would help any because I can't really tell what you're seeing on the screen, but I think this may help. This is a sheet that I have made up, which my students will be receiving in class, which starts out with the first four reflections that we did in a previous section. Reflection across the y-axis, reflection across the x-axis, reflection across y equals x, and reflection across y equals negative x, where you can see xy went to negative xy, etc. Now, there are some others that are common and that we're going to be using, and they are 90 degrees clockwise down here under rotations, 180 degrees clockwise, 270 degrees clockwise, and then we go 90 degrees counterclockwise, 180 counterclockwise, and 270 counterclockwise. Now, this is certainly something that if you don't have or are not in one of my classes, I would recommend that you copy down. It's very, very useful. So, I'm going to put it back up on the board, but again, I think it's hard to read from there, so hopefully you have had a chance to copy this down. Or you can stop the video and do that. So, let's put it up here. And what I have drawn is a triangle, and it's a right triangle because I thought it might be easier to see as we move it around to see what's happening to it. So we have A at 3,5, B at 3,2, and C at 6,2. All right, now I wrote those points down here, and I'm going to go to the chart and see what to do with each one of these. Now I'm going to start with a 90-degree clockwise rotation, which says x, here I'm going to move this up a little bit, which says xy becomes y negative x. Okay, I hope you can see that all right. That's a comma there, supposed to be. All right, so I'm going to take each of these points, I've lined them up like this, and I'm going to take each one of those and figure out what it's going to become. So what you'll notice is the x and y trade places, and the x becomes the opposite sign. So I take 5, 3, but then the 3 becomes negative. So this point is 5, negative 3. So I put the y in the x position, and I put the x in the y position and changed its sign. So I'm going to do the same thing here. This one becomes 2, negative 3, and this one becomes 2, negative 6. All right, now let's see what happens to this thing as we rotate it 90 degrees. Now these are all rotations, what's called around or about the origin. So it's as if a string was attached and we are rotating it 90 degrees, so you would sort of expect that somewhere down in here it would, I can't do these without looking at these things. It doesn't make sense to me without having this chart in front of me. But with it, it makes it relatively easy. So here's what I do. I take the new values. I have one at 5, negative 3. So 5, negative 3 is here. I have one at 2, negative 3, which is 2, negative 3 here. And I have one at 2, negative 6, which is 2, negative 6 right here. And my triangle, and I'm going to take this away because it's just confusing. Here is my new triangle. Now, what happened here is, this is point C, which became 2, negative 6. This here, I should label these probably. This was A, B, and C. All right. Now, point A came around to here, and point B came to, let's see, I hope I have done this right. Let's see, A went from 3, 5 to 5, negative 3. To 5, negative 3, that's right. Okay. point B, let's see, well, let's do C, because I did that. 6, 2 to 2, negative 6, that was here. And point B from 3, 2 to 2, negative 3, which is so that's point B. All right, that's the new triangle, rotated 90 degrees about the origin. And now you can see that this point, that's a 90-degree angle here as I rotated this thing around. All right? Now, you could see if you wanted to, and I'm afraid it'll make this graph too confusing. If I took this point A, let's move these away. You can see that they all rotated 90 degrees. So if I take this dotted line away and make a dotted line up to A, like this, and then a dotted line over here to A, now you can see that's also a right angle, and I could do the same thing for point C. So each one of them moved around 90 degrees. That meant the whole triangle moved around 90 degrees. So that's a 90-degree clockwise rotation. Now, all of these, let me erase these, all of these are going to work in a very similar manner, basically looking at what the rotation becomes. So let's try something different here. Let's take a triangle that is not a right triangle. So I'm going to go from here to here to here. All right, and I'm going to write down the values of those points, and then I'm going to take it and rotate it a different way. So let's say, so xy becomes, now this time I'm going to rotate, I had a 90-degree clockwise, let's do a 90-degree counterclockwise. Xy becomes negative y x. So in this case, they flip again, but now the y is the one that becomes the opposite sign. All right, so these points are 2, 3, we'll call that point A. Point B is 6, 6, 6, 6, and point C out here is 7, 4. All right, now I'm going to write those points down over here. So I have A is 2, 3, and B is 6, 6, and C is 7, 4. All right, now each of those is going to move according to, we said we were going 90 degrees counterclockwise, which is this. So what I'm going to do is take, take this one, the 3 becomes negative and moves in front. So that's the y moving in front and changing signs. So it becomes negative 3, 2. This one becomes negative 6, 6. And this one becomes negative 4, 7. Okay? So the y's became negative and changed places. The x also changed places but did not change signs. Remember, if any of these y values had started out negative, they would become positive, because what we're really saying is opposite y. All right? So let's take these new points and see where we ended up. Negative 3, 2 is right here. That would be point A. Okay. Point B is at negative 6, 6, which is here, B. And point C is at negative 4, 7, which is up here, negative, I don't need to write it, I'll just write point C here. And let's see what happened when we did that. Here is the new triangle, here, here, and here. Now, does that look like, relative to the origin again, it is a 90-degree rotation? Yes, it does. There's a 90-degree angle. And remember, we are thinking of each of these points as attached by a string or a wire to the origin. So when we rotate counterclockwise 90 degrees, we are saying that that angle that's formed with the origin must be moving 90 degrees in this direction, counterclockwise. All right, and again, if we took the other 2 points, attached them to the origin, you would then see that the same thing is happening with those. Okay, now, having set the stage for how you do these, and let me show you one more thing on this, if you can see this. I want you to notice something here. A 90-degree clockwise is the same as, and it's y negative x, is the same as a 270 counterclockwise, y negative x. Well, doesn't that make sense? Because if you go 90 degrees clockwise, aren't you, let's, here, let me just put it over here. If you go from point A here, 90 degrees clockwise, aren't you doing the same thing as going 270 counterclockwise? Because you're forming a complete circle of 360 degrees, 90 degrees, 360 minus 90 is 270. So if that's 90, this one must be 270 the other direction. So there is some symmetry to these rotations. Excuse me. All right. Now, in the next video, what I'm going to do is put these together. So you've seen a slide, you've seen a rotation, you've seen a flip, and in the next video, which will be again section 7.5, part B, we will put these together into more interesting and complex problems. Thank you.